Hello everyone, myself Sagolsam Lenin Singh from IIT Manipur, and I'm going to present online poster for the CompFlu 2021. Title of my talk is Chain Dynamics in Confined Symmetric Ring Linear Copolymer Blends. Here we perform molecular dynamic simulation of 50-50 ring linear copolymer blends and molecular dynamics is performed in NVT ensemble with DPD thermostats where we keep the density of the system at 0.95 and the chain length we consider is below the entanglement length. Um, we systematically vary the ring linear interaction strength from repulsive to weakly attractive by changing the uh, ring and the linear chain interaction cutoff distance RC. At RC equal to 1.12, ring and the linear are repulsive, while we increase the value of RC, ring and the linear become slightly attractive, and with that, the self-organized structure, which is lamellae, is changed from macroscopically separated ring and the linear domains to partially and a well mixed state at really attractive as shown in the figure here, which this mixing behavior is reflected in the size distribution also, where we see the ring has least effect on the size due to this change, while a major effect is seen in the linear copolymer. In this study, our aim is to look at the chain dynamics. So the chain dynamics of the system is investigated by means of the following MSD, mean square displacement quantities. First is monomeric MSD, defined as the mean square displacement of each monomer averaged over the number of monomers, and which we do for the the number chains present in the system. Now, second is the monomeric MSD with respect to the center mass, and the third is the center of mass MSD defined, and each of these are represented by G1, G2, and G3 respectively. On the right, what you see is a figure of MSD showing the G1, G2, G3 as a function of time. As you can see, G1 and the G3 approaches each other after certain time, and then Z3 initially increases together with Z1 but separates out, and Z2 saturates at certain height, and this value of saturation roughly corresponds to the size of the chain. Now on this slide, what you see is a comparison of the chain dynamics through Z1, Z2, Z3 for different ring linear interaction strengths. The important observation here is that for partially mixed or immiscible blend, which is for RC value less than 1.75, the behavior is say almost same as that of the clean linear system or clean ring systems. These are not blends, and for blend with RC value greater than 1.75, where the blends are partially or well mixed, we see a diffusion, a bit a faster motion of the chain, indicated by the higher value of Z1, Z2, and Z3 respectively in all these cases. Now, from this behavior, we can conclude that the quantitative behavior of Z1, Z2, Z3 depends on the ring linear interaction nature, while the qualitative behavior does not. And also we can conclude that for immiscible or partially mixed blends, there is no difference in the behavior of MSD, while for miscible blends, on average, the chain moves faster even with respect to the clean systems. So with this, I would like to thank you for your kind attention. Uh, Thank you.